Welcome to 29th lecture. We are studying stochastic processes, and today we'll study mean first passage time in a Markov process. Right. Mean first passage time is defined for a recurrent for a state present in a recurrent class. Right. We know that the Markov chain consists of recurrent classes and transient states. So for a recurrent class I, the states that are within that recurrent class, we define for each state found in a recurrent class, we define mean first passage time. This means this is the time that a state, for example, let's consider this state in a recurrent class starting from any given state. For example, if we start from here, what is the mean time that starting from this state we will visit this yellow highlighted state for the very first time in the chain, right? So it can also be from any other state, but we have to mention that from this given state, the initial point, what is the mean time that this yellow highlighted state, our selected state, will be visited for the very first time, right? So it is defined for states for states in a given recurrent class. It can be defined for each state in a given recurrent class, and we also have to mention the starting state, right? So we have to mention two states: the state for which we are computing the mean first visit time, the mean first passage time, and the state that we start from, right? So for the ith state is for all other states except the state for which we are going to compute the first mean passage time, the mean first passage time. If S is the state for which we want to compute the mean first passage time in this picture, in this diagram, this is S. This state, this yellow highlighted state, is S, for which we want to compute the mean first passage time. And I refers to all other states in that recurrent class. For example, given this recurrent class, S is the state for which we want to find the mean first passage time, and I corresponds to all other states, this state, and this state, for example. So for all other states, we have the same recursion based formula that we introduced for 7 or 8 lectures before. And for the state for which we want to compute the mean first passage time, we'll keep t for that state equal to 0, right? So this is the mathematical basis of the concept. So let's try to understand the concept better with the help of an example. Here we are given a Markov chain, and fortunately this whole Markov chain consists of only one RC, only one recurrent class, because every state is accessible from every other state in the chain. There are two states, so we want to select state number 1 first, and we want to compute the mean first passage time. This means that we have started from state number 2. And by starting from state number 2, what is the mean first passage time for state number 1? This means after how much time on the average the state number 1 will be visited if we start from state number 2, right? So T1 is a 0 because we have selected S is equal to 1, and we have just studied that T for the state for which we want to compute this MFPT, mean first passage time. We put T for that state is equal to 0. So we have put T1 is equal to 0 here because S is 1 here. And then for all other states that are present in the same recurrent class, we use this formula, this recursion based formula. So we apply this formula, 1 plus this j from 1 to 2 because we have only 2 states, and psj where s is a 1, s is 2, psj pij, and I is 2 here, so we have 2 here, and then tj. And if we expand this, we get t1 is equal to 0 because t1 is 0 here, and t2 comes out to be 5 by 3. So 5 by 3 more than 1 but less than 2, so after 1.66, no, this is 1.1, 1.66 time step, this state number 1 is expected to be visited for the very first time if we start our process from state number 2. So homework 1. We have 2 homeworks in this class. In this lecture, we'll have 2 homeworks. First homework is that previously we set s is equal to 1, the state for which we wanted to compute mean first passage time. Now it's a homework for my students is to put s is equal to 2. And if we put s is equal to 2, we'll definitely put t2 is equal to 0 instead of t1 is equal to 0 that we had in the first case. And if you put t2 is equal to 0, you have to do it yourself, and you have to find the value of t1. This is homework number 1. So recurrence time is the other concept that we will study in this lecture. Up till now, we have studied mean first passage time. That this means that starting from any state in a recurrent class, what is the probability, what is the time, mean time of visiting a given state S for the very first time. But recurrence time means that starting from the same S, S means this highlighted state S. Now we have to start from, instead of starting from any other state in the same recurrent class, we'll start from S. So starting point is different now. So starting from S, what is the mean recurrence time to state S again? What is the mean time? What is the mean time after which the same state S is visited again? This means that given this chain, given, for example, this chain, if we start from 1, what is the mean time after which the state 1 is visited again? For that, we use a similar formula, and we represent with the static. This means this is the recurrence time. This t represents recurrence time. 1 plus j1 to mps is s is the same as this s and tj. So we'll have s is equal to 1, and we have t2 is equal to 5 by 3. How do you define this t2 is equal to 5 by 3? How do you know that? We have just calculated for the same chain that t2 is 5 by 3, right? So now we'll expand this formula T1 static for J1 to 2 because we have only two states. S is 1, so we'll put 1 here, we'll put a 1 here. And T1 static means that after you have visited state number 1, what is the mean time after which it will be visited again? So this comes out to be 4 by 3. T1 is 0. This T1 is 0. And we put everything that we have, T2, the value of T2 that we computed for mean first passage time in the same lecture. And then T1 static comes out to be 4 by 3. This means this is the time after which state number 1 once visited will be visited again. So we can repeat the same problem for state number 2. That state number 2 once visited, what is the time after which, what is the average time after which it will be visited again? This is also left as a homework for my students. Now you will put s equal to, it's a hint, you will put s equal to 2, and T1 you computed in homework 1. In homework 1 you would have computed T1. So the T1 that you computed in homework 1, you'll plug that value here, T1, and you'll write the recursion based formula for T2, this formula. You will derive this formula for T2 static, and you will find the recurrence time for state 2. Right, that's all for this lecture. Thank you very much.